Hi there, I'm Alex Philby. I'm an engineer with the Dell Technologies HPC and AI Innovation Lab. I'll be talking today a little bit about some of the hot topics going on in the lab. There we go. So for those of you that don't know, the HPC and AI Innovation Lab is based in Austin, Texas, though we have a global presence. We have engineers located around the world, and these engineers have deep subject matter expertise in a wide range of topics. So that includes things like computational chemistry, computational fluid dynamics, networking, storage, bioinformatics, just to name a few. And so they can leverage that expertise and wealth of experience to be able to generate best solutions, best practices, and assist customers with being able to, fine tune the solution for the questions that they have. So in particular, some of these projects that we do in the lab might consist of things like technology comparisons. So comparing technology A to technology B, see which one works better for your particular workload, or more common things like within a particular processor vendor, maybe you're trying to determine what SKU works best for your particular application. In addition, we'll do things like optimization for workloads, networking evaluations, storage, proof of concepts, and so on. You'll notice I did mention that we're very focused on your particular applications because at the end of the day, that's what matters most for you. We do run broad-based benchmarks and categories and helps give a wide range to be able to see, what works best in a variety of scenarios. But at the end of the day, you care most about what works on your applications, and that's what we like to focus on. So we are able to do all this by having this large lab. So there's a 13,000 square foot lab with over 1,000 servers, 10 petabytes of storage that's located in Austin. I'm going to call out 3 particular clusters that are kind of our large systems. However, this is by no means an exhaustive list of everything that we have available. We have smaller systems and test beds that we can use and reconfigure quickly for various POCs or other tests. So we have Zenith, which is our Intel-based cluster. Currently, it's a mix of Cascade Lake and Ice Lake systems. The Cascade Lake systems are connected with HDR100, and the Ice Lake systems are HDR. This has got a mix of different storage solutions available, and it's also liquid and air-cooled. All the Ice Lake systems are liquid-cooled. A few of the Cascade Lake systems are liquid-cooled, and all the rest are air-cooled. Next, we have Minerva, which is our AMD EPYC-based system. So that's got mostly Milan processors, still some Rome processors. They're all connected with HDR, again, with different storage options. And all of our Milan, with the exception of a few servers, are liquid-cooled. And then we've got some older Rome nodes that are still air-cooled. And then we have our other cluster, which is Rattler, which as of yesterday has been announced as number 233 on the top 500 list, which we're very excited about. This is our GPU accelerator-based cluster. So it's got a multitude of different system configurations with NVIDIA GPUs, HDR, HDR100 interconnect, as well as different storage options. And we'll talk a little bit more about these clusters in a little bit. So I did mention liquid cooling. For those that aren't familiar, as we tend to get newer processor technology or newer server technology in general, they're getting more and more power hungry, which offers a wide range of different challenges. One of those is cooling. So at the densities that we really like in HPC, as you can see here, we've got a sled in the center as an example. It can be a big challenge to be able to take all that heat that's being generated by the various components and be able to get enough air through the system to keep the system cool enough to operate. So one of the ways to get around this, as we show here, is the CoolIT liquid cooling solution. So this will replace the standard air heat sinks that you would see on a system with cold plates that go on the top of the processors. So this will transfer the heat of just the processors to a glycol solution and out of the system. Now you'll still need some amount of airflow because, as you can see, the RAM and the networking cards still aren't liquid cooled and still require cooling, but it's substantially less because the processors are responsible for most of the heat in a given system. So as a result, your fans are running much lower, which we in the lab like because the systems aren't as loud. And also you don't need as cold of temperatures either because they're not as sensitive. You're not having to push that much air through it. Now, You can see they've got hoses coming out of the back, and on the right-hand side, we've got the picture of the back of one of our Minerva racks. And so these little hoses are quick disconnects. So when you're trying to take the system in and out of the rack, it's really simple. You just pop off. If you've ever scuba dived before, the connectors are similar to the low pressure inflator disconnects that are on your BCs. So you just kind of come over there, pop them, hose pops right off. There's basically no leakage of any kind. Put the system in or out, and you're good to go. So that gives a lot of ease of use, snaps right in, it's great. Previously in the lab, we had a single rack for our high-end Cascade Lake systems. For us, this is becoming a challenge because for the systems we were really interested in for Ice Lake and Milan, they've required a lot more power, and we just didn't have the capacity to cool those with air in our lab as is. So we've upgraded to the CoolIT CHX 750, which is a much larger unit that can hook up to multiple racks. For our particular install, that has the capability of about 300 kilowatts of additional cooling capacity for processors. And we've split that across 10 different racks, so 6 for Zenith and 4 for Minerva. I've got a couple more photos from the install. So the system itself doesn't actually, the chilled water that you get from the facility doesn't go straight into the back of the system. So there's actually 2 separate loops. The chilled water from the facility goes into the back of the heat exchanger for the CDU, which is the cooling distribution unit. And that cools down the glycol solution that's actually flowing between all the systems. So that glycol secondary loop is the green and blue pipes that you see there, and that's what's actually plumbed to your individual racks. At a rack level, we've actually got individual valves and flexible hosing, so you can see in the center and off to the right. So when you want to connect a rack, you put the manifolds that we saw in the previous picture underneath the floor, and you connect it with quick disconnects. This system is very flexible because it doesn't require you to actually have all the racks ready to go on day one, and we didn't. So like I said, we have 10 racks of capacity. On day one, we only had about, I think, 1.5 racks ready to go. So we were able to just hook those up. And then over the next couple of weeks and months, as we added systems and converted things, we were able to plug them in, keep going. We did not have to shut down the system to do this. You just literally hook up the quick disconnect, turn on the valve, make a couple of checks, and you're off to the races. So we really like the flexibility of this system, and we're definitely going to be seeing more liquid cooling as time goes on. Now for particular cluster upgrades. So for Zenith, we added 144 additional, or 144 Ice Lake nodes. These did replace some of our Cascade Lake nodes. These are all connected via HDR. And as I mentioned, these are all liquid cooled. On the Minerva side, we added around 192 Milan nodes. Some of these we upgraded from Rome, and others are brand new systems that are straight Milan. These are also connected with HDR, and all of them are also liquid cooled. Now on the Rattler side, this one's particularly interesting. So we added additional 48 of the XE8545s. These are the EPYC-based processors with the NVIDIA A100 GPUs at 4 per node, an NVLink, as well as 2 HDR connections per. Now, what's particularly interesting about this setup is that this is located in our modular data center and not in our primary lab. So if you see on the picture on the right, that building behind there is actually the second floor as a location for our primary HPC and AI innovation lab data center. For this particular cluster upgrade, we had a bit of constraints in the facilities that didn't allow it to fit for our timeline to get that set up. So we used this modular data center outside of our building to be able to get our system rack configured, set up, and run on time. And that's where it's going to be housed going forward. This facility is particularly interesting because it's customizable. It's as configured, it hosts 11 racks. It's got set up for power, networking. Out in the front there, you can see the cooling. As configured, it's 180 kWs of power, 180 kW of cooling. And we think this can be particularly interesting for those that have issues in their existing data center. Maybe you're kind of pushing up against capacity, you need more space, but trying to build out a giant brand new data center from scratch is expensive. So a solution like this would allow you to be able to stand up what you need with a lot lower overhead, and kind of gives you that flexibility. So that's about all I had. If anybody has any questions.